Okay, the central angle is this angle right here that goes with this intercepted arc. The length of the intercepted arc is r times theta, but in this case you have to make sure that you realize that theta needs to be in radians. If it's not in radians, you have to convert it to radians before you can use this formula. So we have this problem right here. We want to find the length of the arc. We have 4 inches for the radius. Central angle is pi-8, which is in radians, so we get the length of the arc equals 4 multiplied by pi-8, which would then be pi halves inches. Here we have a central angle of 50 degrees, so we have to convert that into radians before we can use the theta in our formula. So our theta then is going to be 5/18 pi, or 5 pi/18. So then I can take the diameter is 12, so that means the radius would be 6. So then using the formula, the length is going to equal 6 multiplied by 5 pi/18, reduce, and we get a length of 5 pi/3, and then it's in millimeters. On this one, this is already in radians, so all I have to do is use the formula. Length equals 16 times 0.95. So the length of the arc is 15.2 centimeters. Here we're talking about the sector, which would be the shaded region for an angle. It's like a piece of pie or a piece of cake. You can use a formula for getting that. It relates again to the fraction of the whole 360 degrees. Remember that theta from our activity is related to the fraction of the circle over 360. So like if this was 45 degrees out of a total of 360, you get that fraction, and that relates to the 2 pi around the circle for in radians. So that was just a reminder. You don't need that right now to do this problem. Okay. This formula again is only good if theta is in radians. If theta is in degrees, you have to convert it to radians to use the formula. So here I want to sketch each sector and find the area. So 13 pi/12. So halfway around the circle is pi, which would be 12 pi/12, and then 13 pi/12 would be just a little bit more. So if we're sketching out that sector and shading it in, it would be that much. The area then is going to be 1/2 times r squared, and r is 10, times theta, which is 13 pi/12. Now I can answer in terms of pi like I've done previously by doing 1300 in the numerator over 24 in the denominator. Then you could reduce that 1300 24ths to 325/6. That would be your answer in terms of pi, and it'd be in square feet. Now if you wanted it as a decimal, all you'd do is multiply by the pi and divide by the 6. For question B, our angle is in degrees, so we have to turn it into radians. So we remember that 45 degrees is pi force radians. Then we can get our area. Oh, and we need to draw it. So pi force is right there. Okay, and that's 1/2 times our radius squared times our pi force. This one has a decimal already, so I'm just going to do the answer in decimal. So I would have 0.5 times 9.5 squared times pi divided by 4. You get 35.44 rounded off, so 35.44 meters for square meters for the area. So here I want the area of a sector. It's 16 inches squared. I'm given that, and I'm given the central angle of 60 degrees. So the first thing I need to do is convert 60 degrees into radians. In radians, 60 degrees is pi thirds. Now I can plug into the formula area equals 1/2 r squared theta. I know the area is 16. I don't know r. I do know theta. So I get 16 equals pi divided by 6 multiplied by r squared. So to get r by itself, I need to multiply by the reciprocal of pi 6, which should be 6 over pi on both sides. So on this side I have 6 times 16, 6 times 16 divided by pi, 30.558, and over here I have r squared, because these reduce and these reduce. So take the square root of that answer, and we find out that r is equal to 5.53. And that would be in inches. Okay, so find r and the arc length. So now the arc length, S equals r times theta, and our theta again was pi thirds. So S equals 5.53 times pi divided by 3, and we get 5.79, and that would be in inches. Okay, angular velocity is things like 45 rotations per minute. It's anything that's going in circles, so it can be revolutions, rotations, radians, or degrees. Linear velocity is a straight unit like inches or feet or miles or kilometers. So a truck is traveling 75 miles per hour. And the truck's tires have a diameter of 28 inches. So that means the circumference would be 28 pi. Pi times the diameter is the circumference in inches. Okay? And remember, one circumference is the same as one revolution, and that's important for our conversion process. So the tires on a truck have a diameter of 28 inches. That is the angular velocity of the wheels in revolutions. What is the angular velocity in revolutions per minute? So I have to get from miles per hour to revolutions per minute. So I need to get from miles to inches first, because the circumference is in inches. So I know that there are 5,280 feet in 1 mile. Then I know that there are 12 inches in 1 foot. So now if I look at this and I reduce my feet and I reduce my miles, I'm in inches per hour. I want to get to revolutions per minute. So now I'm going to go from these inches into revolutions, because right up here I have one circumference, which is 28 pi inches, is the same as one revolution. So one revolution is the same as 28 pi inches. So now those inches reduce, and now I'm in revolutions per hour. One last thing is to get hours into minutes. So 1 hour is the same as 60 minutes. Reduce. So now we look at our units, revolutions per minute, that's what we're after. So now we just multiply the numerators. So we're going to go 75 times 5,280 times 12. And then we're going to divide by the denominators, divide by 28, divide by pi, divide by 60. And make sure you do all of those as divide bys. You should come up with 900.36. 900.36 revolutions per minute. Okay, second question. A pulley has a radius of 15 centimeters and turns at 5 revolutions per second. So one circumference is equal to 2 pi times the radius. So one revolution there is going to equal 30 pi centimeters. Okay, what is the linear velocity of the belt in meters per second? So a pulley has a radius, it's turning at 5 revolutions per second. So there's our starting off. 5 revolutions per second. Okay, so we just said one revolution is 30 pi centimeters. So 30 pi centimeters is one revolution. So now I'm down to centimeters per second. I want meters per second, so I need to convert centimeters to meters. There are 100 centimeters in 1 meter. So now I have meters per second, which is what I'm after. So I'm going to multiply the numerators, 5 times 30 times pi, and divide by the denominators, divide by 100. And we get 4.71 meters per second for the linear velocity. Okay, the area of a sector is 156 square centimeters. So the area is 156. The radius of the circle is 18. We want to find the angle measure in degrees and minutes. So we're going to solve this for theta. So 156 times by 2 and divide by 18 squared. And we get theta is 0.96296. Now we need to remember that that's in radians, so we need to convert that into degrees. So we take that answer and multiply it by 180 over pi to get it into degrees. So times 180 and divide by pi, and we get 55.17 degrees. And then we wanted that in degrees, minutes, and seconds, so then we would times the 0.1737 by 60, or use the calculator, and we get 55 degrees at 10 minutes. Okay, we want to find the area of a sector swept by the spoke of a wheel with a radius of 22 centimeters. The wheel rotates through the angle of 135 degrees. So here again, remember you have to convert the 135 degrees into radians by multiplying by pi over 180.